Hi there, welcome to my new video series for CSCI1061, Programming Workshops 2. I felt that it would be a good idea to have another little video series, kind of like my one from last semester, where I go over some of the solutions to the problems that I posted in the lecture slides. A few notes before I get started with this first video is, first of all, that this is not a supplement for going to the lectures. In the lectures, I'm going to talk a lot more about these topics in depth. I'm probably going to go through the course notes in a little bit of detail, whereas in these videos, I'm probably going to skip over the course notes completely. Second of all is you should not watch these videos before you've attempted to solve these problems yourself. I think that there is a tendency very often to just sort of want to take the shortcut and easy mode to seeing what the answer is, seeing how the problem is solved before actually trying to do it yourself, and I think this is not great for your learning. So my recommendation is, before you continue on with this video, read through all the lecture notes, the course notes. So for today we're doing everything from week 2, structures, classes, and objects. Go through these notes first. This should be your the starting point, because these even have some examples as well that you can look at for figuring out how to go through things. And after you've read through the course notes yourself, then give each of these exercises a try. It's okay if you don't get them all done, but the most important thing is that you figure out what you do know and what you don't know. How much of this can you accomplish on your own? How much of it can you do without my help? Figure out what that marker is first, and once you know exactly what you are able to do and what you aren't able to do, then these videos are maybe a good supplement for you to figure out, oh, I got stuck on this part, but then the video helps you to answer that question, and then you can proceed onwards to either complete further exercises or fill in what other gaps that you're missing from your learning. So without further ado, let's dive into these exercises. Okay, so create an animal class. What sorts of attributes and methods might an animal have? This is a very open question, so I'm only going to answer it in one particular way right now. Maybe in class I'll do it a different way. Include those attributes and methods in your code. Instantiate 2 different animals in your main method. So a few things before we begin, just to point out with regards to this question. Class is called animal. Anytime that you define a class, you usually should have a capital letter, and anytime someone's telling you here is a class you should make, very often you should use the name that's given to you. Attributes and methods are going to be there, so those are variables that belong to the class and functions that belong to the class. Which ones are appropriate? Sometimes this can be open, sometimes you're going to be dictated, like you must have X things in it. But in general, it's never a bad thing to include more attributes and methods if you need them to get stuff to work. But also, don't it's not necessarily the case that we want our animal to include literally every possible attribute that might make sense. We'll put in a few of the most important ones maybe, and then we can always add on to it later. Instantiate. This is a word that I don't know if we've used very much, but when we define our animal class, all we've really done is we've sort of built this blueprint to say this is what an animal looks like. You can think of it as, filling in a textbook with a description of this is an animal, but we don't actually have an animal. We want to actually make one. So in our main method, we're going to need to actually create 2 animals of 2 different kinds. Maybe we'll assign them different values and so on. And then that'll be our first exercise. So let's give it a try. So in videos, we are in a new folder. This is week 2, structs, classes, and objects, and we're going to make a text file. You could do probably a lot of this with the notebooks, but I think I'll stick to using the terminal for a while. Maybe in the second half of the class I'll transition over to using a bit more of the notebooks, but for now let's stick to what we're used to. So we're going to rename this as animal.cpp. Now, it is possibly the case that you might want to make a header file for this that determines that declares what all the properties of the animal class are, and then we can define them later in animal.cpp. I'll skip over that for now, but in a few weeks when we start working on things like makefiles, you are going to want to separate what actually has the code in it versus what's just describing what the code's going to do. So let's start off our programs the same way that we like to usually. This line of code in particular is one actually we'll see disappear at some point this semester. But we want a class called animal. don't forget the semicolon after your class description. And okay, so now we got to think about what belongs inside of our class. So every class has two different kinds of members, either private ones or public ones. I don't think we necessarily need to have both, but let's think of for a second about things that we need to have. Definitely, if we're going to use a constructor, it should be a public member. If you have a private constructor, you probably can't actually build the animal class, and that's not ideal. We also, we'll see what we actually want our animal class to have in its constructor, but for now we can just leave it blank, that's okay. Probably want to give it a name, that makes sense. That should be a string. What else might an animal have? I guess number of legs, that's an integer. Legs. Maybe we'll have a, not a biologist, maybe I have to look this up. I know animals have, animal kingdom, species, well, et cetera, et cetera. What are the things? 7 classifications. That's what we want. Now I don't know if we want to go so absurd as to list all 7 of these things, but maybe we can list maybe family. How about family? This seems like a good one. I don't know if I'm going to be botanically accurate, so if there are any biologists here, I'm probably going to be very bad about this, but we're going to put family, and we're just going to pretend for a moment that family is going to be things like reptile, or bird, or mammal, or so on, even if that's not actually correct, because I don't know, we'll fix that kind of stuff later. And in private, we can work on that at a later time. So maybe let's do a method as well in addition to the constructor. So we got our animal, our constructor, we got some variables. Let's say make a run. How about that? And our run is going to return, let's just do void. We'll make it void run. And then we can define it right after. So let's start perhaps with our animal constructor. Actually, first thing we should do is compile this, because if it doesn't compile, then that's probably not great. To make sure it compiles, just make sure you can put in a main function. It doesn't really need to do anything. Save this. Let's pop open a terminal, compile it, and make sure we didn't break anything just yet. Any typos? No, we should be good. Okay. So let's declare some stuff. How about our animal constructor? So remember, anytime that you're going to declare or define a function that belongs to a class, you need to indicate what's the class, 2 colons, and what is the name of the method. In this case, it's the constructor, so it's just called that. Note that the constructor is also a little bit different from every other method. Over here, I had to indicate that run is a void type, so that means it doesn't return anything. Over here, I don't actually need to write anything, because the implication is that when you call the animal constructor, it builds an animal. That's all it does. With other methods, you need to specify exactly what it's supposed to do. So if I construct an animal, there's also sort of an implicit return this referring to whichever animal has this method. It's sort of implied that if you're calling the constructor, as soon as the constructor is done running whatever code you want it to run, it will then build your little animal and then give it back to you. So you don't need to actually write any return statements in here, but if you do want to set anything up, you need to do that here. So this is where I might need to do something like, for instance, what might I want to do? Let's set our, how about just, we'll have it do one thing. Our name is going to be equal to a named animal, just for now. Now I think this will run okay. Let's double check if it compiles all right. Yeah, it seems fine. Another way that might, I'll double check that this works, that might be better formatting is to say this dot name, which should also compile, I believe. No, okay. Request for member name, which is a point. Okay. So here's a good error to run into. Maybe you meant to use the little arrow here, and it turns out I did. And so here's the reason for that. When we are talking about classes, there's really 2 different ways that you can have a reference to a class. You can either have the actual object itself, the actual animal itself, or you have a pointer to it. We've seen pointers from last semester, so hopefully those are fresh in your mind, and if they're not, you definitely want to go back to that. Now, the word this is not the same as the animal itself. It's a pointer to the animal. So since this is a word that indicates that is pointing to an animal, I could, I suppose, put asterisk this dot, but that's kind of annoying. Instead, we'll do arrow, and we'll call it unnamed animal. So now this will compile. Great. And just to make sure that we know this is working, it's always good to have some code in your main method that actually prints some stuff out, so you get a little bit of feedback beyond compile doesn't compile. So we'll build our animal. Let's make it, I don't know, a dog. Dogs are cool. Is an animal. And then we will output our animal is named, and we'll do dog.name. Run. Our animal is named unnamed animal, which makes sense. Let's walk through what happens in the code right now. Step 1. So remember, we define everything, but I don't actually make anything happen until I hit my main function. Now here's where all the lines of code go one by one. I make an animal. The variable name for my animal is dog. This is not the actual name of the animal yet. I call the constructor, and the constructor is going to implicitly return an animal object, which is why I can assign it to my dog, and it's going to set the name of this animal to be unnamed animal. And so when I try to output, now here's where you'll notice something's a little different. Over here I have this with the arrow. That's because this, with the green text, is a pointer. But dog over here is not a pointer. In fact, dog here is the actual dog. So when I try to grab the name of the dog, I don't use the arrow here, I use a dot, because I have the actual dog itself. Now I could do this another way, which is to say I want a animal pointer, dog. Now I think this will work okay, although over here I'm going to need to change this to be an arrow. I might be wrong. Let's double check. So added an asterisk, added an arrow instead of a dot. Complain? Yeah, okay. So cannot convert animal to animal star. And that's because over here we're implicitly, I guess it's not returning this, it's returning what's at this. Since I'm returning an actual animal object, I want to change that into I want to get a pointer to that object. Now, one way to do this is I can grab the address of this, and I think that should work okay. Let's find out. Just out of curiosity. No, okay. All right, you're not allowed to do that. That's okay. We have a better way to do it anyway. And this is something that you may have needed to do last semester if you were working on the Stack Lab, which is anytime that you're trying to build a new object, you need to use the new keyword. Now this I think should work. Yes, good, thank you. Compiles, runs okay. So what is the new keyword? The new keyword tells the computer that you're looking to make a new one of these objects, one of these new animals, and you want to make a pointer to it. And the benefit of doing this is that we can make as many dogs as we want now. I can make 100 dogs. I guess the limit is how much the computer can handle. But I'm not restricted in terms of how many animals I can make, like I would be if I was trying to make an array. An array has a fixed size, but by using the new keyword, I can make as many dogs as I want. Now, let's go with, I guess we'll leave this all here. This seems fine. What did our exercise say we had to do? I think we've completed exercise 1, right? Instantiate 2 different animals. Okay, so let's make one be dog, that's a pointer. That'll be our first animal. And then make a second animal. Our second one will be, of course, cat. But cat here will not be a pointer. We're just going to use just a regular animal here. And that way we can see sort of the difference between dog and cat. Compile. All right, now let's not name them unnamed animal. How about we give them some properties? So dog name should be Cheeto because that's my dog's name, and cat name should be Cheddar because I have a friend who has a cat named Cheddar. All right, let's try that again. Oh, I made a mistake. Right. Easy mistake to make. Cat, not a pointer. Dog is a pointer, so we have to use the dot here. Try that again. Great. Cheeto and cheddar. Okay, I think that wraps up the first exercise, so we can delve into the next one. Okay. Modify your animal class to have two different names. One is their colloquial or normal name, and the other is a taxonomic name. Okay. The taxonomic name should be a private variable, alright. Add a public method to string that writes out both names and call it in your main function. Okay, so let's copy this so I don't forget everything it says. We'll dump it in here. Okay, two different names. So right now we just have name. Maybe we'll have, in addition to the name of the animal as an entity, we'll also have the name as in like the type of animal. So let's do, so we'll do string colloquial name, and we'll do as a private variable string taxonomic name. Note that it's good formatting here again to stick to using all lowercase for variable names, and if they're multiple words, you can separate them with underscores. So, okay, we got our taxonomic name is here, our colloquial name is here, and now we need to string. To string, depending on the implementation, sometimes you want this to return a string, sometimes you want it to print a string. I think for this, let's make it so that since it says the public method writes out both names, let's make it a void method. So void toString, and now we need to make void animal :: toString, and it's going to print out a colloquial name is also called a taxonomic name. All right, and there's our toString. So let's well, first off, I guess we have to figure out what that is for for dogs and cats, right? Well, I guess we know for sure that the colloquial name for a dog is a dog. So dog colloquial name is dog, and the cat's colloquial name, cat dot colloquial name, is cat. Our dog's taxonomic name is, and now we gotta look it up because I have no idea. Dog taxonomic name is Canis familiaris. Okay, the domestic dog. Sure, domestic dog. And how about the cat's taxonomic name? Felis catus. Classic. Cat dot taxonomic name is Felis catus. Okay. After we output here, let's call our toStrings. So dog arrow toString, and down here we'll do cat dot toString. And if we did this all right, it should all work. We've got our new function here. It's public, so we can access it. Taxonomic name we can't access unless we're in the animal class itself. So within the animal class where I have my toString method, I can access a taxonomic name because it's in the same private area. But over here, if I try to do something like output cat dot taxonomic name, it will give me an error. I'll leave this as a comment for now, just to make sure everything works properly, and then I can show you the error that will come up with that one. So, do I have any typos? Let's find out. Yes, I do. Is private within this context? Oh, right, yes. So, I have a bit of a problem which is that I can't actually assign this. So this is where I need some public functions that will allow me to do so. So, and this is, I think, actually part of the next exercise. Yeah, so just in order to see this works, we're gonna kind of step into the next exercise, which is to modify our animal class to have getters and setters for its taxonomic name. So we'll start on that one, I suppose, and then we'll move on to the next part right after. So getters and setters. For any time you have a private variable, you need to have a public method that allows you to actually access it or change it. Sometimes it might be the case that, for instance, a taxonomic name might have restrictions on what it could be. For instance, you might want to ensure that anybody trying to change the taxonomic name of an animal is only allowed to do so with 2 words, something like that. All kinds of different scenarios you can possibly come up with. But importantly, since we need to modify the taxonomic name of our dog and our cat, and we can't do it like this, because we get literally the error that I was going to replicate, but showed up anyway, we're going to need to give us some public functions that will let us do it. So right now, we don't really need a public function to get to the taxonomic name, because we're just going to be changing it. So let's do set. To set a variable, you don't need a function to return anything, because you're just changing it, but we will call it set. And I guess for this, I think it's okay to have it lowercase. In fact, I think all of these should be lowercase. Yeah, let me fix the formatting here. You should always have lowercase for everything that's not a class. So to string. We will use camel case, where you have the to string and the S is capital. But this really should be a lowercase t. There we go. Okay. Now, set taxonomic name. And this is going to take as a parameter a string, because that's what taxonomic name is. And since this function is really short, I'm just going to write it right here, because all the function is going to do is be taxonomic name equals s, which is my string parameter. I could go down over here and write this whole thing out and make it all long, but you may as well, anytime you have a set function, because it's usually just 1 line of code, it's often better to just write it right away. Okay, now that I can set the taxonomic name to whatever string I want, I need to change this line of code here to be dog arrow set taxonomic name, and as a parameter, canis familiaris. Similarly over here, cat.set taxonomic name, Felis catus. Let's give that another try. There we go. Our first animal is named Cheeto. A dog is also called a Canis familiaris. Our second animal is named Cheddar. A cat's also called Felis catus. Boom. And we are done there. All right, that's 2 exercises down. 1 more to go. Okay. All right, so we've already got started on this one, although we need to finish it, which is to have a getter for the taxonomic name, and then we'll move on to this thing over here. So let's copy that in as our next step. But before we do that, we need a getter. So string get taxonomic name. Doesn't need any parameters, and also this is 1 line of code, so we may as well just write it here. And all we're going to do is return the taxonomic name. Yes, please. Thank you. If anyone's wondering how I'm it seems like I'm typing really fast. It turns out that the Jupyter environment is really smart, and it can actually figure out often when I am trying to type a variable that's already there. So if, for instance, I want to type taxonomic name down here, I can actually just do probably TAX and then hit tab. Boom, and it fills in the rest of the letters. A similar sort of thing happens with the terminal over here. You'll notice I didn't have to actually type out all the letters of g++ animal.cpp all the time, because I'm only really running 2 commands over and over, compile, execute. So if I want to compile, I actually can just hit the up key a couple times, up, and there it is. And if I want to run, up, go. This only works because I've already typed them in once, but once you've typed them in, this actually keeps track of any of the commands that you've entered. You can go up and down to switch between them. Just some shortcuts that might save you some time. Now, what do we have to do next? Create a second class called habitat that represents the animal's home. Include in this class a private variable that represents the owner. Sure, so Something else to keep in mind here, which is I'm going to be a little inappropriate, not inappropriate, poor form perhaps, which is in C++ and in programming in general, you probably almost never should actually have two classes in the same file. I'm going to violate that for this example, but very soon in the course, we will start going through how to combine many different multiple files and classes together. And in those cases, you should not have two classes defined in the same file. It's usually pretty bad form. So if I was doing this properly, so to speak, I would actually make a new file. I would call it habitat.cpp, and I would have the habitat include this file. I suppose I can do that anyway. Sure, you know what, why not? Let's try it out. We're going to cover this in, I think, a little more detail later on in the course, but just for the sake of, doing this perhaps the proper way, let's give it a shot. I need all of this, actually. New file, habitat.cpp. And we're going to include animal.cpp. I think I need, is it double quotes or single quotes? I think it's double quotes. And just to see, let's double check. Habitat. Okay. You know what? On second thought, we'll save this for later. This is something that's going to take some more time, I think, to work out. So for now, I think we're just going to we'll get rid of that habitat, and we'll yeah, that's fine. We'll put it all in the same file. But keep in mind that later on in the course, we're going to see how to combine lots of different files together like this, and then we can start talking about how to link them and that sort of stuff. But for now, let's just keep it simple. One file, class habitat, private and public variables. In this case, we don't really need to have anything. Or I guess maybe let's have the owner be private. Maybe people don't want to know that you're the owner unless you have a password or something like that. So we're going to have an owner, and the owner happens to be an animal. So we're going to have an animal owner, just like that. Anytime you have a private variable, you should have getters and setters for it. So we're going to need to have a void set owner, string s, owner equals s, and we'll have a animal get owner, which returns the owner. And we'll say, just for fun, we'll also have a the name of our habitat. Why not? So we built a habitat. Let's instantiate it. Well, we haven't actually built a habitat. We've described what a habitat is. We also don't have a constructor, so we probably should do that. Habitat. In fact, this will also make one line, so we'll just put it in here, and we'll just say the owner by default is null, and then we need to actually give it an owner. Okay, so let's make a habitat down here. Habitat h equals habitat. So note that I'm not making this one a pointer, it's just a regular object. So I need to use dots anytime I'm referencing any of the members. Now I want to say h dot set the owner. And we're going to set it to be our dog. Then what we can do is we can let's give it a name, I guess, too. The name is going to be, let's say, Michael's couch. It's definitely his habitat. And what we can do is output so let's get the name of the dog. If we want the name of the dog, we need to do h.getOwner. Get owner. So this gives us the dog. Now from the dog, we need to get the dog's name. So the dog's name will come from here. Lives on h.name, and that should be good. All right, let's try it out. Well, okay, lots of mistakes. What did I mess up? Right, okay, so the owner is not a string. We have to set the owner to be an animal, animal A, so the owner is going to be A. That makes sense. Okay, try this again. In fact, let's clear this mess. This text is real big. Also, I really hope this is visible in the video. Next time I will remember to zoom in so people can see, but hopefully the text isn't too tiny. G++. Worst case, you can always go see the code, at least. Animal, compile. Okay, what else did I mess up? I can't assign it to be null. I guess that makes sense because it's not a pointer. So we're going to, for now, I think perhaps get rid of this. Actually, we'll just set the owner to be a default animal with no properties or anything like that. Okay, try it again. Now what? Cannot convert and right. So remember, hold up here. Cannot convert animal star to animal. Right, because dog is a pointer to a dog. It's not actually the dog. So if I want to actually make the dog the owner, I have to get the dog that's there. So let's try that. All right, now what? Right, so get owner returns me the actual animal, not the pointer to it. So I don't use the arrow, I use the dot. Lots of things that can mess up with some of these programs, so it's worth definitely testing them thoroughly before you hand anything in. Okay, now what? Oh, I missed an arrow. That's a simple one. Okay, finally. Cheeto lives on Michael's couch. We got it. Took us a little while, but lots of things that can easily trip you up. I've been doing this for a while, and I made a whole bunch of mistakes, and you saw all of them. So here is all of our code. It is here. I guess I can get rid of this comment here. But all of this completes the exercises that we've seen in the lecture. Note that if you were really to do this much more professionally, I suppose, is you really should put the habitat in a separate file. And secondly, there should be a header file for animal. It should be called animal.h, and it should describe all of the things that we have in here, but it won't actually have any of the code that makes it run. It won't actually say, for instance, animal to string looks like this. That stays all in animal.cpp. And the reason for this is that when you're working with really big programs, people don't want to have to read through all of the code to get to the points that matter. Most of the time when you're working, for instance, in the industry, there will be cases where you're looking at a class, and the class is really, really complicated, has all kinds of things going on, but very often you don't need to know how the class works internally. You just need to know what it allows you to do. For instance, if I have an animal class and it has a toString, do I really care about how that string is conducted if I just need the string? Not really. All I really want is the string out of it. So, as somebody who might be using this animal class, if I didn't really care about the code, but I did care about what methods are available, it's useful to have that header file that just describes, here is what these functions do, here's how you can use them, and don't worry too much about the internal impact. Of course, in this course, you'll be building all the internal stuff, so that's going to matter to you a lot. But in coding, we don't always just care about ourselves. We also care about the people who are going to read this, which, at least for this class, will also include your TAs. So also good to add some documentation. I don't have any comments in here, so that's probably not ideal. Might be good to add some in just to describe things like a class that represents an animal with its various properties. Not a great comment, but something like that is always good to have. Probably any class that you write should usually have at least one comment that says what the class is for. And many methods often, if they're not obvious, such as toString, should tell you what the purpose of the method is. So if I were to write a method that says run, you might want to explain what does it mean for an animal to run. Okay, I think that wraps up everything I want to talk about for today. Hopefully this video was useful. Some of this stuff should be, I think, refresher from last semester, so hopefully there's not too much that's going on that's new here, but it is worth practicing some of these things, especially if you're not super comfortable yet with working with pointers and using these arrows/dots. If you haven't done a lot of this yet, it's really worth taking the time to get used to it, because this semester we're going to see a lot of classes, a lot of pointers, we're going to kind of assume that, like, going from this point onward, that you're very comfortable with it. So good luck, and I will see you in class. Take care. Bye-bye.